Hello everyone, I'm Ayush, and today I'll be presenting our work on Deepweed classification using advanced neural networks. Our group number is 93. So the motivation behind choosing this problem is that weed identification is an important task in agriculture, and in the traditional methods there were manual labor work involved, and it could lead to high manual overhead, and it's a time consuming process. Also, since there are humans involved, it could lead to human errors. That's why we decided it would be important to incorporate machine learning techniques into this domain. That's why our problem statement is to incorporate CNN-based architecture to identify different type of each species so that it could increase the time in identifying and lead to better results. So for this project, the data set which we choose had roughly 17,000 images. There were total eight types of species. So the task was multi-class classification, and the images were collected in the field of Australia, and the data set which we obtained was from Kaggle. So this is the distribution of uh, the data set. As you can see, there is a class imbalance problem. Majority of the data is of negative type, and all the other classes are has roughly similar distribution. So we had to do a good amount of data pre-processing before applying the machine learning models. So this is the methodology which we followed. First, we load the input. Then we did aspect ratio normalization during the pre-processing part. Since there was a class imbalance problem, we did data augmentation, and we also computed class weights. After doing all this data pre-processing part, we splitted the data into train, test, split. After that, we trained the model, and we tested on the test data set, and upon that we were predicting our new output labels. So this is the baseline model which we created in the first half of our project. We decided to go with ResNet 152. As you can see from the training accuracy, it was decent, but the validation accuracy was not up to the mark. So there was a model overfitting issue in this scenario. So we decided to go with a lighter model. So we opted mobile net version 2. But since in this scenario too, the validation accuracy was not up to the mark, so then we decided to go with transformer based model. So we decided to go with vision transformer with attention. So this model is our final model. It had around roughly 20 million parameters, and all the parameters were trainable. And this is the patch size, transformer depth, and embedding dim. Head counts were 5, and these are the results which we obtained. The training accuracy, as we increased the epochs, were around 95%, and the validation accuracy was also around 90 roughly around 90%. And on the left hand side, you can see the predicted label, and our model was successfully able to identify a good amount of uh, labels correctly. So this is the final comparison of all the models which we built during our entire project. As you can see, during the first ResNet 152, it had only 33.6% accuracy, and it had maximum amount of parameters. So based on that, we concluded that since this is a large model, it could have been suffered from severe overfitting issues. Same for the mobile net version 2. It had 2.6 million parameters, and the accuracy was roughly the same. So it was lightweight, but it could have been suffering from a model underfitting. So ultimately, we decided to go with 12 million parameters model vision transformer with attention mechanism. It had 90.2% accuracy, and it is the best one which we obtained till now. It is a balance. It it's able to generalize well. So this is the prior work. All member have prior experience in deep learning and computer vision project. Although the agriculture and this type of images, these domains specifically was new to us. It was challenging for us, but we were able to implement the solution using base of our knowledge. And I think we had done a good amount of work, and the results were promising. And these are all the references which we followed throughout the project. And yeah, thank you so much.